first of all, this is exam-centric, really basic stuff. So a lot of you may know this, some of you may not, but it's still kind of useful information. And brought my own hardware, so that's always good. So it's kind of cool to have the hands-on portion of that. So what I'm going to do is I'm going to cap off what I was talking about last time, a couple months ago, which was VLANs. And VLANs are logical segmentation of networks. And so to start that off, what I'm going to do is I'm just going to create a black hole VLAN. And what a black hole VLAN is for whatever ports you're not using on your switch, put in the black hole, and they cannot logically access any other device on that switch. So nobody can just plug into that switch and get information or access or connect to whatever other device. So that's the first thing I'm going to do here. Am I in and out here? Is everybody? Okay, good deal. All right. So I'm going to elevate by configure terminal or conf t. And I'm going to specify VLAN 999. And then from here, all right, so here's what I'm going to do. I'm going to get all of the interfaces here. Interface range, or I'm going to just spell it here. I'll spell out the commands for you. Interface range fast Ethernet 01 0/1 to 48. And the command to pass to assign all those ports to that VLAN is going to be switch port access VLAN, and then identify whatever VLAN that is. In this case, it's 999, and we've already created it above. And once it passes, all those interfaces are now in VLAN 999. So if you were to access one of those and try and get on a production side of this switch, you wouldn't be able to, logically at least. So from here, I'm going to go ahead and create 3 other VLANs and just kind of simulate what that would, having multiple VLANs on a switch would look like, because I'm going to take that to, later on, I'm going to take that to the router here in just a couple seconds or a couple minutes, take that to the router so that those VLANs can communicate with each other, and then talk a little bit about security. So, and most of this stuff is either study material for the CCNA or is taken from that type of studying to some form of real-world application. So, all right, so I'm going to go back here, exit, and then create another VLAN by using VLAN, and then specify whatever VLAN. Normal VLANs are in the range of 1 to 1005. Beyond that are extended VLANs, and they're not really as useful, and they're more complicated, so I'm just going to go with normal range VLANs for right now. And so I'm going to specify VLAN 10, and we can give it a name. Let's just do PCs, okay? So now that I've got that, I'm going to go into a port, an interface, so I'm going to enter an interface, and that command would be interface, and then specify whatever that would be. In this case, it's going to be 10. And then use the same command I used before, switch port, access, VLAN 10. Okay, so just a real quick note. All right, give me a second here. Now everything, I didn't get my gigabit Ethernet ports here, but what I did first was take all the ports and put them in a black hole, and now I'm going to one by one bring them out into an actual usable VLAN. The reason I did that is it just takes a lot of time. If you do it the opposite way and you go from the default VLAN into and then try and get chunks of range UR and put them back into the black hole. So it's just a little quick note. Another way to create a VLAN is going into, and instead of creating the VLAN first, is going to the interface first. So I'm going to go to interface fast Ethernet 12. And that's just for simulation. Like whatever interfaces I'm using are just for me because it's easier. It doesn't really matter otherwise. So, and then from here, pass that same command, VLAN 20. So we haven't created 20 yet. And so what it's going to do, if I just pass the command, is it's going to create it by itself. All right. And then from here, I'm just going to do the same thing again and along with my little study plan here, I'm going to create one more VLAN interface F016. And I need to spell interface correctly. 016, and then VLAN 30. All right. So if I issue the command show VLAN brief, I can see that I've created, well, I didn't give names to the other ones, but I've created 3 VLANs and assigned them to ports, and everything else is in the black hole, so it can't be used. So let's say, for instance, all of our PCs are on this VLAN, VLAN 10. They cannot talk to, let's say VLAN 20 would be the printers, can't talk to the printers, or let's say VLAN 30 was the servers, they can't talk to the servers. So anybody that plugs into the switch can't automatically communicate with whoever's is connected physically to that switch. So that's kind of the idea. That also, let's say you, for whatever reason, you do want to, okay? I want to be able to print something, to print a document, to give the printer a job, and because I can't communicate, I obviously need to send that data out of the VLAN to another VLAN that those devices are associated with, and that's called inter-VLAN routing, of course. So to do that, there's a couple ways to do it. You can do it, I do have a layer 3 switch, and you can use a layer 3 switch to do inter-VLAN routing, but I'm not going to do that today because then everything would be done on one device and it would get obnoxious for, I think, everybody to explain sort of how all that works. And the other way is by using a router, and that's what I'm going to demonstrate. So now that we have our VLANs created on the switch, as soon as I can fumble around and get my console cable hooked up here, I'm going to enter the router. I didn't save my configuration, which is awesome. So so first thing I'm going to do is show you the interfaces. So show IP interface brief will give us a list and a quick status. Here, I'm going to raise that up for you. List and a quick status of all the usable interfaces on the router, and I have 2. And what you would do generally to set up this router to communicate is you would go to configure terminal and enter the interface. And let's just do this one right here, gigabit Ethernet 0/0. And that's not the way that's supposed to look, but I think it'll work anyway. Boom. Okay, so now I'm in that interface, and from here you would just give it an IP address, and whatever, 192.168.0.1, and then a subnet mask, and that's normally how you would assign those. So the difference between physical interfaces and sub interfaces, which are what are used to have routers communicate inter VLAN, is by specifying a sub interface with a dot and then whatever value that sub interface has. So to make all that make sense is to say, let's use the same command and then specify a 10. 10 really doesn't matter. You can number the sub interfaces any way you want to, but for me, it's easier to identify .10 with VLAN 10. So I'm going to go ahead and create that. So now, as you can tell, our prompt changed to sub interface, and we're in sub interface gig 00.10. So, and then from here, the first thing you have to do is specify the encapsulation, because frames that are used in VLANs have a tag within the frame, and so they're composed a little bit differently. So encapsulation is different. So you have to specify .1Q for the encapsulation, and then after that, whatever the VLAN number is. So the router can specify what VLAN it belongs to. In this case, it's 10. So that's what it looks like. Boom. And then, like any router interface, you would just put your whatever IP address. And for my scheme here, I've put I'm going to put the third octet as, you know, relating to the VLAN, and then the last one for, or one as the router, and the subnet mask of 255, 255, 255.0. And from here, everything that's on VLAN 10 should now be able to communicate to the router. I'm going to go ahead and do that for the other ones real quick. Don't mind me. But in general, so with the other two VLANs set up, it's the wrong key. Here we go. Okay. So I'm just going to do the same process for the other ones that are simulating actual segments or virtual segments of the network. And once I get that finished, all of my VLANs should be able to communicate through this router. Is everybody understanding that so far, or am I clear as mud? All right, I'll take your silence as yes. Okay. 22.168.30. .0. Okay, so routers come out of the box with all the interfaces shut down. So now that I have all that set up, in order to activate the interface and have all the VLANs communicate with one another, I'm just going to exit the sub interface and go back into physical interface and issue the no shutdown command to activate the interface, and they all should come up here in just a second. Okay, the one thing I forgot to specify is that the interface on the switch should be a trunk link, so I'm going to set that up real quick. It should already be set up, but I'm going to go ahead and show you how it works. So whatever switch is connected to the router that's doing inter VLAN routing has to have that port as a trunk port connected to the router. The rest of them can be access ports. And for those of you who don't know, access ports are generally used for hosts, and those are the ones that have the VLAN tag. And trunk ports, well, trunk is a Cisco proprietary word for tag ports, but a trunk port takes all VLAN data and sends it out whatever port that is. And that's the difference between a trunk port and an access port. So I'm going to get into that interface. In this case, it's 48. And I'm going to force that port into trunk. It should already be trunk, but I don't have additional devices to be able to prove that all of this is working, but I tested it at home before I got here to make sure that all the steps that I was doing was correct, and they worked when I did them then. So that sort of caps off what I began to bring up 2 months ago, which was VLANs. You'll notice that I didn't make a router sub interface for VLAN 999 because it's a black hole. There's no reason for anybody to access any of those ports. Okay. And the only other step that I didn't specify for the switch was to shut down all the interfaces that are not being used. So everything that's in a black hole, I specify range and shut them down. And for the sake of time, I'm not gonna bore you guys with that. So that, like I said, that caps off VLANs. That's kind of how they work. And so I'm gonna move on to some of the security side of what I was going to be talking today. So with all of that set up, a lot of information can be gained from the broadcast on your local segment. So I got Wireshark pulled up, and I'm gonna give a couple of CCNA based sort of what you see Can you guys? Low? Is it my battery? Or no? Okay. So, of what you can see on just a basic setup, and how that can create vulnerabilities and how to stop that on a CCNA level. Of course, there's equipment that could do all this for you nowadays, but still the essentials are there as far as you don't want unnecessary information broadcasted on your network, et cetera, et cetera, et cetera. So, there's a few things that I just kind of want to rehash for those of you who know this, and some of you don't. There is a protocol called CDP, or Cisco Discovery Protocol, that sends out the information of whatever device you're using on the network. And the non-proprietary version of that protocol is LLDP. Okay, intentionally sends who you're, like, what the device is and whatever information is associated with that device out on the network for anybody to have. So if it's misconfigured or not properly configured, then I mean, anybody who's monitoring network traffic, or if somebody knows how to gain access to monitor traffic, it's pretty simple to figure out what devices are on the network. And let's see if we can't find an example of CDP here. There we go. Okay, so right here I've got highlighted, if you look at packet 166, I'm not sure how well you guys can see that on your screen. Obviously, Wireshark specifies the vendor of the MAC address automatically, so obviously that's out there. And you'll see that CDP also uses a couple of different protocols. So that what does that tell you? That tells you that that data can be manipulated to look like something that is not from a malicious side, but that's another story. I don't know as much about that as what I'm about to talk about. So if you look at the content of the packet here, okay, I'm in the wrong packet. Apologize. Give me just a second here. Okay, there we go. If you look at the packet here, the device is specified, the model and the make of the device, not even just the series, but the exact type. 48 port switch is up there for anybody to have if CDP is enabled. Okay. And also even what port it's attached to. I'm not sure exactly why that's there. But so that's what information CDP can put out there for anybody to see. Okay. So to shut that down is just a pretty simple command. There's a couple things you can do with CDP. So if you look at CDP, if you just put the CDP question mark command and enter, then you've got a couple of variables here, okay? And the command that we're going to use is run, okay? Except we're going to use a negative command, no CDP run, and we should not be receiving CDP frames, so your device should be protected. I'm gonna show a little bit more of that. I'm gonna reactivate it real quick and show you how detailed it can get. Okay, so I'm gonna go back. I'm gonna activate it again. CDP run. Go back to Wireshark. See if we can pull one up here. There we go. Okay. So I'm connected to the router here. So if I pass the show CDP, let's say somebody had malicious access to a Cisco device, okay, and they passed the show CDP neighbors detail. Oops. So do show. By the way, if you're elevated in a configuration mode, all you have to do is pass the do command in front of that. The only problem is after that you won't have context sensitive help, so the question mark is not going to help you out. So do show CDP neighbors detail. except details got to be spelled right. So there's that device. There's our router interface right there. Okay, so we have, if somebody gained access to the switch, then they could have, well, I guess that doesn't matter if they gain access to the switch. Disregard what I'm talking about right now, because it doesn't matter. Anyway, so originally what I was saying was CDP puts information on your segment, or on a segment, about a Cisco device, and it also sends out LLDP messages, which is, like I was saying before, a non-proprietary version of that. And to prevent those from being broadcast, you just issue a no LLDP, similar to your no CDP run command, and that information won't be sent out on your network. Another piece of information, I'm not sure exactly how much STP messages can be used, but I've heard of SNMP messages being manipulated to look like network-friendly data when they're masked to be something else. But the bottom line is that spanning tree messages or any other type of messages don't need to be sent out of host ports. That's unnecessary message going to hosts, which can be used against the network or any other devices on the network. And this is a spanning tree message right here. You can kind of look at some of the structure of the data here. Like I said, I don't know how they can, how those messages can be spoofed, but that's information about the device. Obviously, if spanning tree's on the network and a hacker knows what spanning tree is, they know that a device that's sending out spanning tree messages that's additional information that can be used to pose an attack. And the bottom line is, to stop that, you would go into the interface F010, and you would issue spanning tree BPDU, which is the type of message that spanning tree produces, a bridge protocol data units. BPDU guard, actually I think that's one word, GUARD, enable, boom. And then I think Cisco devices still send out some form of spanning tree message regardless of whether you have that on or off, but still you're cutting down a lot of the spanning tree messages. So if you look up here, there's an entire block of CDP, and there's some even DTP messages. I'm not sure. DTP is dynamic trunking protocol. Each interface on a switch will negotiate to other devices if it's a trunk, which is also a vulnerability. So that's what DTP is, and you can also shut that down, because again, that's another message that's put out on your network that gives an attacker some information about your device. Or even if the interface is brought up and a hacker gains access to a port that is running through the spanning tree process before it chooses whether or not to be a trunk port or an access port, then the hacker can fool the port into forcing it into trunk to gain all the information off of that switch. So it's a lot of technical information. I'm assuming that the crowd I'm talking to is pretty well versed in Cisco, so if you're not, I apologize. I can break it down. Just ask me questions, and I can make it make more sense. So I apologize if that is the case. And I forgot my last topic here, so give me a second here while I try and recall. So I was going to talk about Wireshark, and okay. Switches have a MAC address vulnerability. So the way a switch saves MAC addresses is when they receive a message from a device and it doesn't have that MAC address saved, it saves it from the source. Now, as far as the destination goes, wherever that data is going, if it doesn't know where it's going, it'll flood it out all of the ports. okay? Which is, by the way, that spanning tree exists. Spanning tree exists to prevent, let's say you have two switches connected together, and they keep sending a message to find out where an address is. If they don't find it, the switch will reproduce that data over and over again and consume all the bandwidth in your network. And sometimes it can be intentional, which is an effective denial of service attack. Can be, which is why spanning tree that's what spanning tree does. It prevents those broadcast loops. But on the other side, if you have an attacker that keeps changing their MAC address and sending messages through the network, if they want to overload the switch and have it just send messages without, I can't remember exactly how it works, but it doesn't discriminate anymore based on the data that's incoming or outgoing because it's overloaded. The buffer is overloaded, and so what an attacker will do is change their MAC address, or every message that's sent out will have a different MAC address, and the buffer will overflow, and over time all the buffers that save that MAC address will overflow, and then the device will be basically a hub, and it will repeat all the information that it receives, and that's its default. That's the switch's default. It just repeats and broadcasts all the information that's sent to it. And the way to prevent that from happening is to enable switch port security. Now that's from the source. As far as the destination MAC address, that's a different story, but we're just talking about source for now. So I'm going to go into, and I'm going to just stay in this interface up here, interface F010. And then from here, the first command I have to issue is a global switch port, TCHPORT, port security command, and this activates port security in general. Okay? Okay, so what it's telling me right here is that I'm gonna have to troubleshoot a little bit. What it's telling me right here is switch port F010 is a dynamic port, which means that it dynamically chooses whether it's static or access, and I'm just gonna force it into an access port real quick. So I didn't have to exit, but what I'm gonna do is switch port mode access, and that just forced it into a non-dynamic static access port. And I'm going to pass that same command before, and now it works. So from here, what I'm going to do is I'm going to specify how many MAC addresses I want on the port. And in my case, I only want one. In some cases, maybe you want a couple, like there are your switching devices or whatever. Or maybe it's a wireless access point with a certain number of devices. I'm not sure. So what I would do is specify the maximum amount of MAC addresses I want on that particular port. Maximum, in this case, 1. Okay, so once you define how many MAC addresses can be on that port, you have to tell the switch which one you want, or which ones you want the switch to remember, or which MAC addresses it's going to allow. In this case, 1 MAC address. And you can do that dynamically by specifying MAC address, and you can either from this point specify an actual MAC address or dynamically through the argument sticky. So we're just going to pass sticky. I had another MAC address to be able to demonstrate with a syslog server, or kind of a simulated syslog server. It's not up right now. How it works when it rejects, but I don't think I'm gonna have time for that tonight. So once I've specified that I want that MAC address remembered dynamically, then you have to worry about, okay, well, what does the switch want to do if a MAC address violates that rule? And so the command to specify that, and there's 3 options. Switch MAC address. Sorry, not MAC address. Violation. And then you have 3 options for violation. I may actually pull up here a syslog server. Except I can't remember what MAC address I was going to use. Put that off for another time. I apologize. So to run through just real quick what these modes would be, protect it just drops the data. So if you pass that command, it's just going to, whenever it receives data from a MAC address that's not specified, it's gonna just drop it. Restrict drops it and sends a message. So if you have a syslog server set up, it'll send a message to that syslog server when a violation has occurred. And then shutdown sends a message and also shuts down the interface to where you have to manually go in as an administrator and reactivate it. And that's basically how to stop that MAC address buffer overflow and a use of switch port security. There's also other applications of switch port security. So that's kind of a basic rundown of what I was going to talk about. I've got a little bit of time here. It was really technical. It sounded really good in my head when I was going through this talk earlier. So if you have questions, if I wasn't clear on anything, please feel free to ask. I'll be happy to answer your questions. So. All right. Not a problem. Thanks, guys.